Welcome to my Pernosco demo. Brendan Gregg wrote a great blog post showing how to use GDB to debug a crash in a Python-based system profiling tool that uses libbcc and LLVM to compile BPF scripts. I thought it would be fun to show you how you could use Pernosco to debug that same bug. To get things started, I reproduced the crash and recorded it using the RR record and replay tool. Then I submitted it to Pernosco for debugging. After a few minutes, Pernosco emails me back with a link. I click on the link and the Pernosco UI comes up. In the top left we have the console output from this example. It doesn't look useful, so I'm closing that. This is the call stack for the crashing thread. We can see that some Python code is calling into some TTY related C code. The light green box shows the currently selected stack frame. This view shows alerts that are probably relevant to debugging. This shows the source code for the current stack frame. The light green line is the current line. The orange highlights show the lines executed in this function call. It looks like we've crashed while reading some global variable, which is weird. Maybe this code is using macros in a funky way. I can't figure out what's going on from the source, so I'm going to look at the instructions executed. There's a tool for that in the toolbox. This shows us the faulting instruction. We can see that in the previous instruction RCX got set to 0, and now we're trying to load from around there, and of course that crashes. We can see that RCX was loaded from the address in RSI, which was set to point to the curterm global variable. So we loaded the value of curterm into RCX. Now I'm clicking on the value of RCX to tell Pernosco to show me where that value came from. Over on the left, Pernosco is showing the data flow steps that led to RCX being set to 0. The last step is just that instruction that loaded curterm into RCX. The second to last step shows us where curterm itself is set to 0. The stack shows us that a function terminal has colors is calling another function set curterm. Terminal has colors is being called via some LLVM stuff, which is being called by BPF module create C from string, which is being called from the Python tool. The source view shows us that it's passing null to set curterm. As you'd expect from the name, set curterm copies its parameter straight into curterm. Let's go back to terminal has colors to see why it's doing this. The comment says, extract a structure allocated by setup term and free its memory through a really silly dance. So clearing curterm is apparently to avoid a memory leak or something like that. Looks like you're supposed to call setup term before calling these cursors functions. Let's look at all the calls to setup term in this recording. There are two. This is the one from terminal has colors. This one has been called through Python. Going back to where the crash occurred, we can see ncursors code being called by Python here too. So I conclude that Python code initializes the ncursors library, then calls into some LLVM code that undoes that initialization while checking whether the terminal has colors. And then the Python code tries to use ncursors and crashes. Looks like an LLVM bug to me. Brendan Gregg reached the same conclusion. You can read through his blog post to see how he used GDB to do that. You see that compared to other debuggers, debugging with Pernosco is a lot more direct because we have the whole history of the program execution instantly accessible, and we have powerful tools for visualizing that history and traversing it. Now if you like what you've seen and you'd like to have this for your own debugging, please get in touch.